Say it again, 93.4.
Yeah.
Oh, just put your grade there. All these are your grades, all your grades, your scores.
Okay, you got 3 parts. Week 12, here we go. Correlation coefficient. This is a big deal. This is to see if there's a relationship between 2 variables. You have 3 parts of your homework this week, but look, you get 2 weeks to do it. It's not due until December 3rd. And I know you guys, you're gonna wait till December 2nd.
Yes, sir.
You know, oh my God, how crazy to do it this way. And I swear I debated whether to make this due next Tuesday while it's still fresh in your mind, but then it's Thanksgiving week. It's just so hard. And then to ask the grader to grade it during Thanksgiving week, that'd be hard too. So December 3rd, putting it off is crazy. Here's the deal. Today, you're learning how to do the written part of this assignment. On Thursday, we're going to talk about those 2 Excel parts. But this formula is the key to today, or the written part of that formula, of that homework. Let me explain this formula. To start with, you're going to be given the correlation coefficient. Thursday, we're going to talk about how you calculate the correlation coefficient, but for now, you're being given. And once you're given that correlation coefficient, you're going to multiply it times the square root of the sample size minus 2, which, by the way, for correlation hypothesis testing, the degrees of freedom is always the sample size minus 2. Everybody hear that? The degrees of freedom, when you're doing hypothesis testing for correlation coefficients, is always the sample size minus 2. So there's what's happening there. Your denominator is taking that correlation coefficient and squaring it, subtract it from 1, square root it, then divide the numerator. This will give you your test statistic. All right, let's start with correlation coefficient. Some of you got introduced to it if you had me in 301, because we did briefly talk about it. And what I really emphasize is the fact that it lands somewhere between 1 and -1. It's point something. And always between 1 and -1, point something. Here's the deal. If the correlation coefficient is close to positive or -1, like 0.99 or -0.99, then it's a very strong relationship, either positive or negative relationship. Does this sound familiar? Some people had 301 from me, starting to sound familiar a little. Remember, I specifically said you not only you're telling me whether it's a strong or an average or a weak relationship, but I need to know if it's positive or a negative relationship. So you're telling me the type of relationship. In 301, it was all about you describing the relationship. Strong, average, or weak, and we're going to talk about how to determine that in a second here, and then positive or negative. The closer to 0, the weaker the relationship. So if I said -0.15, that's over here in the weak category, but it's negative. It's a negative relationship that's very weak. -0.155, 0.115, or whatever, close to 0. So it's kind of like this. So that's the first step. Now, once you know the correlation, or calculate it, but I'm giving it to you this time, you plug it into here to get your test statistic, and then everything's the same after that. It's no different than everything else we've been learning all semester. Once you have that test statistic, you can do p-value, do critical value. We're not going to do confidence intervals for correlation coefficients. We're not going to do confidence intervals, but you got to be ready to do a p-value or a critical value at any time. P-value or critical value. And I'm reminding you how to find the p-value right here. Matter of fact, I should be reminding you how to find, I don't have it memorized. T, is it dot, INV, or no dot?
B is a dot.
Is it a dot? I, N, V, and then there's something in there. Is it the significance, or else is the confidence, or I don't know. We'll look that up. Somebody look that up, please. All right, so anyway, you got 3 parts of this homework. The written part's going to be the easiest of the 3, I think. It is, oh, you gotta have degrees of freedom also. So it's the significance or double the significance, and if it's 1 tail, it's double. So here we go. You have the significance is going here, and then this is degrees of freedom. And then you gotta decide if it's one tail, you're doubling it. And if it's two tail, just significance only. Okay, there's your reminder. Everything's the same once you get to the test statistic. You're only doing T here. We're only gonna be talking about sample correlation coefficients, sample data. So you're only doing T, there's no Z. Once you get your T, you're plugging into one of these, you're using these to either get your critical value or get your P value, and then you compare it. It's that easy. Oh my God, this is almost too easy. Is this class getting easier? It's just getting easier because everything's been built up to where everything makes sense because they're all related to each other. You're using the same Excel almost the whole semester. All right, so now, here's the written assignment. You're even given the hypothesis. Now notice how I'm writing the hypothesis here. Instead of using letters, I'm saying the correlation coefficients either equal to 0 or not equal to 0. I'm using, this is a two-tail. Matter of fact, I better go to the PowerPoint at this point. Hang on, here they are, right here. So we have a two-tail. Here is how it's expressed using a variable, but I just like putting the word correlation coefficient equal to 0 or correlation coefficient not equal to 0. There's your two-tail. One-tail, correlation coefficient less than equal to 0, correlation coefficient greater than 0 is the alternative. Now, or the opposite direction, less than and greater than equal to 0. These hypotheses are so familiar now. All you need to say to yourself, what goes on the left, which variable or words go on the left, and you know what goes on the right is the 0, and what should I be using in the alternative? Because you know the null hypothesis is always the opposite of the alternative. Focus on what should be put in the alternative, a less than, a greater than, or a not equal to. So, whoop. I'm going to go back to this PowerPoint. I want to point out a few things. Here's an example of some data. What I want to point out here is you have 3 columns of data here. Notice, what is that? This is the monthly debt payments for 26 different cities in that first column. Also, for the same 26 cities is their mean income for that city, for people in that city. The mean income in thousands of dollars, 103,500, 81,700, 63,000. Unemployment rate is the third column for each of those cities. So think about how much data you have there. But what you're going to be asked is, what's the degrees of freedom? And it's all about how many, where's the data coming from? How many places the data is coming from, -2. So in this case, you have 26 cities, the degrees of freedom is 24. Even though you have 26 times 3, you have 3 columns of data there. There's a lot of data, but they're all coming from the same city. It's how many different cities are being used, which is 26, -2. There's how you figure out your degrees of freedom. Now, if I said to you, hey, there's a relationship between the monthly debt payments and the average income in a city, how much the average amount they pay in debt, and how much the income. The more the income, the more they're going to pay off towards their debt, is what this theory is. So you look at the numbers there, and you say, and if I said to you, hey, we end up calculating a correlation coefficient of positive 0.87. How would you describe it? Strong, positive correlation. Meaning there is definitely some kind of reaction there going between the two. It's not saying that the higher the income is causing the higher payment. It's not saying the higher payment is causing the income. Correlation does not describe what causes this. It only determines whether a relationship exists or not. Now I want to make sure you realize, I'm going to show you this graph. This is what a positive relationship looks like. If it were a negative relationship, it'd be the opposite direction. But if I could draw a straight line here, and I said, I want you to draw a line that touches as many of these dots as possible, kind of through the middle of the dots. And it would look like this. Right there. That would be angled upward. That's a positive correlation. Anytime you're graphing a correlation, it looks like that, it's positive. All right, now we're gonna talk about sample covariance. You can see the formula for that, but what I wanted to focus on here is the correlation coefficient. But what the formula, you're gonna be given this correlation coefficient. You don't have to calculate this. Even if you're using Excel and have the raw data, you're gonna be using Excel to calculate the correlation coefficient. But there it is manually if you ever need to. This is the formula I want to point out. Whoops, where'd it go? There it is, right there. This is how you find the test statistic once you have the correlation coefficient. And that's what I put up here in words. I don't remember which page this is on. I didn't write down the page number and I forgot my book this morning. But it's right out of the book. Chapter 14 we're on right now. So it's towards the beginning of chapter 14. It is basically saying you take the correlation coefficient, you multiply it times the square root of the degrees of freedom. There's your numerator. The denominator is where the work is. You square that correlation coefficient, then you subtract it from 1, then you square root it. There's your denominator. Now you divide. That's how you get your test statistic. Where's the example? I'm trying to find the example. I didn't write down where it's at. Oh, it's on the slide, that's why. Boom. There's the Excel function we're going to be using. CORREL equals CORREL, and I'll teach the rest of it on Thursday. But that's the Excel function we're using to find the correlation coefficient. Let's say now, we just had some sample data. We just calculated the correlation coefficient, and it's 0.8675. Someone put it in words for me. What kind of correlation is that?
Wait, what was that?
0.8675. Strong positive, I heard it. Strong positive. It's a strong positive correlation. And it says this is what we calculate between the yearly income of a city and the debt payments. So there is some kind of positive linear relationship, a strong positive relationship between these two pieces of data. Hang on, let me get to right here. If we were to use Thursday when we use the computer output, it's going to look kind of like this. I want you to look at it carefully and tell me, if we manually calculated that test statistic, what would we have gotten? Anybody see it?
8.5.
There it is, 8.544. 8.544. I want to show you though how that's calculated. Where is it? Right here? Right here? Right here? Right here? Here it is. It said that the correlation was 0.8675, and you guys told me that's a positive correlation, a strong positive correlation. So I'm just pretty much doing the formula. Take that correlation, multiply it times the square root of the degrees of freedom. There were 26 cities minus 2. Then take that correlation and square it, 0.8675 squared. Now subtract it from 1, then square root it. You get all the way down here. Now divide the denominator and the numerator. 8.54525 is your test statistic. Look how huge it is. We usually get 1 point something, 2 point something. I mean, maybe a 3 point something, never an 8. Sure enough, let's plug that in to get, we're going to assume this is a two-tail. And at this point in time, let's assume it's a two-tail, and we'll plug it into our DIST. 8.54525 degrees of freedom, 26 minus 2, or you just put a 24 there. How many tails? 2 tails. Look at this, 9.634 e to the negative 09. That means you got to move the decimal 9 places to the left. 0.000000009634. Almost 0. It's so small. We're comparing this to 5% significance. This is way below 5% significance. Therefore, we can reject the null hypothesis. What does it mean to reject the null hypothesis? It means that the correlation between these two variables is significant. If we can't reject it, it could have been randomness that called it close. But because we're rejecting it, it's trying to tell us that the significance between these two variables with that kind of sample size, don't get me wrong, 0.8675 is not that significant in other examples. Maybe the sample size is different. But in this case, with a 26 sample size, 26 different cities, it's significant enough for us to reject the null hypothesis, meaning that there is significant relationship between these two variables.
I didn't know if it was one to like.
We haven't gotten there yet.
Oh.
We're almost there. We gotta read the words. We haven't gotten to that part of reading the words yet. Hang on. The p-value is approximately 0, so at 5% significance, we can conclude that the population correlation coefficient between debt payments and income differs from 0. Now, here are some is this, I can't remember what I was gonna call this, but the correlation coefficient captures only linear relationships. That's right. It's only letting you know if there's a relationship between them. Either it's gonna be strong positive or strong negative. When you get numbers that are average or weak, it may not be telling you there's a relationship at all. The correlation coefficient may not be a reliable measure in the presence of outliers. Outliers is when you have data that's nowhere near the regular data and could throw things off when it comes to calculating the correlation coefficient. And the correlation does not imply causation, meaning we're not saying that higher incomes are what's causing higher payments, or we're not saying higher payments on debt is causing higher income. We're just saying there's a relationship between them, that there's some relationship between them. All right, now I want to try another one. Are you ready? I'm going back to the formula, to this. Oh, all right, you ready? Here we go. You've just been given this problem. We haven't determined how to tell whether the hypothesis is two-tailed or one-tailed yet. So I'm still giving you the hypothesis. One-tailed or two-tailed? One-tailed it is. The null hypothesis, or the alternative hypothesis, is less than 0. The null is greater than equal to 0. It says there's 30 observations. What's this? Sample size. What's your degrees of freedom then? 28. Correlation coefficient is negative 0.60. Now we haven't talked about how you determine if that's strong or average. What numbers do we want to use here? When do we say, okay, that was strong, and when that's average? I'm just going to throw what I usually use, which is 0.75. Anything from like around 7.5 or higher, I call that strong. Negative 0.75 or positive 0.75. And then as far as weak, I'm going to go here 0.25. 2.5 or less, that's weak. Negative 2.5 or less, that's weak. So in between 0.25 and 0.75, we'll call that average, I guess. Something like that. I probably should have gone maybe even down a little more, maybe like 0.67, 0.33, to break them into 2/3. But I'm just going like that for now. Don't get me wrong, when I give you a correlation, it's going to be obvious whether it's strong, average, or weak. It's not going to be right there by the border. So but my question right now is, how would you describe this one? Average what? Negative 0.60. It's an average negative correlation. Significance says 5%. 5%. Are you ready? Here we go. Get me started. How am I going to write this out? Ready? I'm going to get my test statistic. Negative 0.60 times the square root of 28. I can put 30 minus 2 or just go ahead and calculate 28. Now I got to do this. This is going to be, watch out, this is negative 0.60 squared. I'm putting parentheses around that because what's going to happen when we square this? Yeah, it'll be positive. It won't be negative anymore. Minus 1. All right, then square root the whole thing. Ready? Let's get the calculator out. I'm showing you how I do it. This is the work you would show me on a quiz if I'm manually asking you to calculate. Tell me whether you reject or not reject the correlation coefficient relationship. So I'm going to go ahead and start this. I'm going to start with the numerator. Square root of 28. So I'm taking 28. I'm going to square root it. Then I'm going to multiply it times 0.60, but I got to make it negative. There we go. So here's my numerator, negative 3.1749. Negative 3.1749. Is that correct? 7? Okay, that's a 7. All right. Now I'm going to try. I'm clearing this all out. Hang on, where's my clear? Here. Make sure my memory's clear. All that's clear. I'm going to start down here. I'm going to first square this. Then I'm subtracting from 1. Then I'm square rooting. So I'm going 0.6 Now look, I'm gonna make it negative, but it doesn't matter, because once you square it, the negative's gone, 0.36. Now I'm gonna subtract it from 1, so I make it negative, and I add 1, and that's just how I subtract from 1. So now I'm at 0.64. Now I square root it, and my denominator is 0.8. Is that right? Oh, this is a big number. So here we go. Now I'm gonna do the last step, which is divide these two. Negative 3.1749, I gotta make it negative, divided by 0.8, that's it, 0.8? Boy, this is a big number. This is equals negative 3.9, let's go, how many digits here? 6, want me to go more? 9, let's make this a 9, how's that? Negative 3.9. Now I'm saying use p-value. If I'm saying use the p-value approach, here we go. Help me out here. Equals t d I s t parenthesis.
Negative 3.
And you never put a negative. Never.
Oh, drop the negative.
You gotta drop the negative. Don't forget. You gotta drop the negative. Equals t d I s t parenthesis. Drop the negative. We're using a positive 3.969, comma, degrees of freedom, you guys told me is 28. And is this a one tail or two tail? One tail. So our p-value is, look at that, 0.000, this is 0.000, 0.3 zeros, and then there's 228. Is that less than or greater than 0.05? Less than. Since that's less than 0.05, do we reject or not reject? Reject. And we don't put it in the form of a sentence yet because we're not at that point. We're just determining what it's going to be. Wait a minute now. We misread the directions. It didn't say p-value. It said use critical value. Should I keep going?
Can you just go up one? I just want to see the one.
Oh, sorry. There you go. I took this number right here, 3.1749, and got rid of the negative and put it in the first number of the parentheses.
Why did you use 28 for the degrees of freedom?
Because it said the 30 observations, and the degrees of freedom are always the number of observations minus 2. Minus 2. So 30 minus 2 is 28. What did I put? 28.
Isn't degrees of freedom minus 1?
No, not for correlation coefficient. It's always minus 2. The formula is sample size minus 2. The degrees of freedom is always going to be minus 2 for correlation. Okay, but we're not using p-value. Now all of a sudden we're using the critical value. So here we go. I'm going to equals t dot I and v. Is that right? I and v. What's the number I put here for the significance?
0.10.
0.10. Why 0.10?
Double.
Got to double it because it's a one tail, so 0.10, comma, degrees of freedom, 30 minus 2, 28. Our critical value, let me put it back up there. Whoops, why is it negative? Did I do that? Wait, that's not right, is it? Wait, is the formula T dot INV or just T DINV? That's why, because of the dot. What the heck, you guys? Hang on, let me get this dot out of here. Oh. There, no dot. So our test statistic is 1.70. I'm sorry, our critical value is 1.70. Our test statistic is negative 3.96. Is our test statistic inside or outside the critical values? What? Outside. Because our test statistic is outside the critical values, we have evidence to reject or not reject? Reject. Because we're outside the critical values. Negative 3.1749 is outside negative 1.7011. Oh my God, this was too easy, wasn't it? Oh my gosh, these correlation coefficients are too easy. What does it mean? We rejected, that means there's some significant difference between the correlations of these two variables. I don't know. We'll figure it all out on Thursday.
Wait, Professor.
Any questions?
What do we compare 1.70 to? I forgot.
we compare 1.72 to our test statistic that we calculated, the negative 3.969. This is outside, farther away from zero than negative 1.7 or positive 1.7. I want you to review this homework real quick. This is the first part of your homework that's due December 3rd, but you may say, you know what, we could do this today. We could literally have this done today. It says, consider the two hypotheses. Correlation coefficient equals 0, correlation coefficient doesn't equal 0. It says the sample consists of 26 observations and has a sample correlation coefficient of 0.22. Show your calculation details to calculate the test statistic. Give the Excel equation to find the p-value, then explain if you can or cannot reject the null hypothesis. You can do this homework now. Go ahead, Noah.
There's no significance to compare it to.
There's no significance on this homework? Oh. Darn! Darn! Oh, hang on a minute. I gotta look at the answer before let me see something. Hang on. Let me get this back here. I can't believe I didn't put a significance on that. Hang on. Let me look at the answer. I wanna make sure I give you the right significance. This is week 12? What week are we in? I used 5%. I used 5%. Let me get that off here again. Let me go back here. Here. Let me put right now. Use 5% significance. There we go. Save. Everybody got it? Use 5% significance on that homework. No, there's 2 Excel spreadsheets also that we're gonna learn on Thursday. This is like 1/10 of the homework. Oh my God. All right, I'll see you on Thursday. Is it Thanksgiving yet? Don't forget to sign in if you forgot.